Okay, welcome back. And today we're going to start section 3, and we're going to talk about addition and subtraction of matrices. So we're going to take an example. So in this example here we have different types of furniture and different models of each type of furniture. So let's say we have a company and they have two types of furniture, sofas and chairs, and each of those two types come in three different models. And so we have 10 pieces of furniture that are sofas, Model A sofas, and then we have 12 that are Model B sofas, and 5 that are Model C sofas. And then chairs, we have 15 that are Model A, 20 that are Model B, and 8 that are Model C. And so we can use this table with this information to easily create a matrix that has all the information within it and just have the numbers. So a very easy way to organize data. And so this is very commonly used in in manufacturing and in business. Now, how do we talk about size of a matrix? Well, the size of a matrix is determined by the number of rows and columns. And so when we talk about matrices, we always say the size of the matrix is always determined by the rows first, then the columns. So if we have a matrix that has 3 rows and 2 columns, we would call that a 3 by 2 matrix. Um, if it has 3 rows and 3 columns, then we would call it a 3 by 3 matrix. If it has one column, one row, one column, then we would just say it's a 1 by 1 matrix. Or if it has just one column, uh, no rows in one column, we would say it's just a 0 by 1, and so on so forth. So now, any matrix with the same number of rows and columns, we call that a square matrix. So like a 1 by 1, 2 by 2, 3 by 3, those are all square matrices. Now a matrix with one row is just going to be called a row matrix. Okay. Oh no, I misspoke. I'm sorry. There's no such thing as a zero. Um, I don't know what I was thinking. I'm sorry. I'm not. Uh, what was I thinking? One row. A one row matrix is we can call that a row vector or a row matrix. Um, so that would be like a 1 by 1 or a 1 by 2, 1 by 3, a 1 by 4. There's no such thing as a 0 by 1 or a 1 by 0. I misspoke there. Um, so now a matrix with one row is a row matrix or a row vector. Okay. A matrix with one column is going to be a column matrix or a column vector. Now, matrix equality. So what do we mean by when we say that two matrices are equal? Well, they can only be equal if they have, first of all, have the same number of rows and columns. Okay, so they have to have the same number of rows and columns, and each element in one matrix is the same as the corresponding elements in the other matrix. For example, in this matrix here, we have this matrix 2 by 2 and another 2 by 2 matrix, and we're saying they're equal. So they could be equal because they do have the same number of rows and columns. They're both 2 by 2 matrices. And so that's going. Now this says this, if we say that this matrix is equal to this matrix, then not only do they have to be the same size, but this element has to be the same as this element. This element has to be the same as this element. This has to be equal to this, and this has to be equal to this. So all corresponding elements must be equal. So that would mean that x would have to equal 2, y has to equal 1, p has to equal -1, and q would have to equal 0 for that to be equal. Okay, so equal matrices just means same size and all corresponding elements must be equal. Now adding matrices. Now adding matrices, you can only add matrices that are of the same size. So you can only add a 2 by 2 matrix to another 2 by 2 matrix. You can only add a 3 by 2 matrix to another 3 by 2 matrix. You can only add a 1 by 3 to another 1 by 3, or a 3 by 1 to another 3 by 1. So they have to be the same size. Okay, and so the way you add the matrices is you add them element by element. So you add the corresponding elements together, and that's how you add two matrices. For example, if we see these two, we want to add this matrix to this matrix. Now, first of all, we can't add these two because one, they're not the same size, so we're done. We can't add these. This is impossible because this is a 2 by 4 matrix and this is a 2 by 3, so we can't add those. Okay, now these two here are the same size, so we can add these. So what we would do is we would add 3 and 1, 4 and -2, 5 and 4. So this 3 plus 1 would equal 4. So the first element would be equal 4. Then we would add 4 and -2, which is 2. And then 5 and 4 is 9. And then we would add 1 and -2, which is -1. 2 and -4, which is -2. And then 3 and 8 is 11. Okay, so again, this solution here, the sum does not exist for part A because they don't have the same size. And here, since these are the same size, we can add them, and we add them element by element. Okay, just like we did here. And so here's the matrix. Now, what about subtracting matrices? Subtracting matrices is exactly the same, but you subtract corresponding elements of the matrix. And order does matter. So x minus y means you have to take elements of x minus the elements in y. So x minus y is not the same as y minus x. So the associative property, or excuse me, the commutative property does not work for subtraction of matrices, just like it doesn't work for subtraction of real numbers. So if we look at these two, we're going to subtract corresponding elements because they are of the same size. So 3 minus 1 is 2. 4 minus a -2 is going to be 6. 5 minus 4 is 1. 1 minus a -2 is 3. And then 2 minus a -4 is 6. And 3 minus 8 is a -5. And there we go. And so there's our matrix. Now, we could do this in the calculator easily. We can create our matrices under the matrix menu under Edit. So if you go into the matrix menu under Edit, you can create a matrix A and B. And you can, by just doing the matrix math under the same matrix menu, you can calculate easily by just plugging in matrix A and then minus matrix B, and it will give you the end result, as long as they are the same size. Now, if you accidentally try to subtract two matrices that are not the same size, you will get an error message on your calculator. Okay, that's the end of this section. Again, make sure you go through the examples in the text. There are plenty of examples in the textbook for this section that are extra. So by all means, go through those, do them yourself. Again, write down your questions. And if you get stuck on anything you're not sure, bring those to class and we'll work them out in class. Make sure you watch the videos in their entirety and you take notes, and then make sure you bring all your questions to class so we can do that and practice these things in class. Once you practice these, they will become easier to do. Next time, we're going to talk about multiplication matrices. Now, this one is a little bit more complicated, much more complicated than adding and subtracting matrices. So, until next time, keep practicing, keep watching, and keep asking questions in class. See you tomorrow. Bye-bye.